Hello and welcome to the video on section 6.2 and 6.3. I went ahead and extended this homework to be due this coming Friday, I believe November 2nd. So let's get started and let's start off with what you need to be comfortable with in section 2. And this is about the z-score distribution. And this is a distribution of all of our standardized scores. Okay, and if you remember, the z-score distribution is how many standard deviations, or the z-score is how many standard deviations one particular point is from our data. And the mean of all of the z-scores would be 0 and the standard deviation is 1. So whenever you see this guy as a mu and this guy as the standard deviation, the sigma, you know we're talking about the standard normal. And the reason we call it the standard normal is because we could transform standard normal distribution. We could transform any x value into a z using the formula here, okay, which everybody should be comfortable with. Go by that. Okay, so for example, if the average of a test was 50 and the standard deviation was 5, okay, now this would be everybody from your population, and if you get somebody from your population that comes and gets, say, a 60, okay, so you could see that this is two standard deviations away, so that'd be 60 minus 50 divided by 5, which is 10 divided by 5, which is equal to 2. So if you have a 60, the z would be equal to 2, which is over here. Okay, so basically 6.2 just deals with finding the area under the curve on either side. Okay, so we could kind of ask this three different ways. Okay, we could ask this kind of three different ways, and you have to be comfortable using StatCrunch, but you should also understand the idea that we're finding the area under a curve, which is essentially, didn't want that, essentially the same thing as, okay, how often would this happen as a percent of the time, or a percent of the population. So I might say, find the probability that z, or the percent that z is greater than 1.2. So then you come to 1.2. Since this is a greater than sign, you would shade to the right. Okay, so this is one way. This would be your lower bound, and your upper bound would be somewhere over here. Okay, but StatCrunch is going to take care of all this for you. If you were doing it on the TI-83 or 84, you would do second vars, okay, hit number 2, which is normal CDF, and you put 1.2 and then just put in a very, very large number like a million. Okay, that'll give it to you. Okay, now another thing is, another way we could ask is I could be interested in the lower bounds. So remember, the mean of this is always 0. That means I'm in the z, so this is z's. That's 1. I also could say, well, what's the probability, or what's the chance that z is less than 1.6? So that's 2. Say this is 1.6. But see, this is a less than, so I'd find this shaded region here. Okay? And that's another way that StatCrunch could ask. Or another thing that they could say is between. Okay, between. So I could say find the probability that it's less than negative 0.11 and or greater than 0.1 but less than 2.2. So this is asking in between. See, this is a negative 0.11, so it's pretty close to the 0. And here's 2.2, so it's pretty far from the 0. So I'm looking for this shaded region right here. Okay, so these are the three ways that say this. These are three ways. If I give you a z, you could find an area, or you could find a percent. That's the three ways that you need to be comfortable with. Okay, now also we could go backwards. I could give you a percent. Okay, I could say give you a percent and you need to find the z. Find the z. Okay, so what would say I could say what's the z for the top 10%? Okay, so what you'd want to do is you want to draw a graph. Remember, this is 0. You want to shade this in. The top 10% would be here. That's 10%. So I'm actually looking for the z. So in your calculator, this is the inverse norm. We can use a table, but generally we'll just use our computers, use our StatCrunch. Okay, so we'll go ahead and do an example like that. They said the bottom percent. You just have to learn how to cut it up and then look at the computer. So let's go ahead and pull in some of the examples that we have. So this is we'll go to example number 3, and if you read this, it has a mean of 0. A mean of 0. So we know we're on our standard normal, even though they're talking about temperatures. Standard deviation 1. Find the probability the random selection is greater than 1.1. So 1.1 is just a little bit less than, a little greater than 0. And then these are some important words here. Greater. Shows you greater. So I'm looking for the one that says 0.11. Greater, not negative 0.11, but 0.11. So my answer would be C here. Okay. So, and the probability is, okay, so here's where you have to learn to get the probability. Now we could use our tables, but we're just going to use StatCrunch. So let's see if StatCrunch wants to open here. Okay, so I'm going to pull this over. Let me make this smaller. Okay, now I could use my StatCrunch here. Sorry. Is that going to disappear again? Yeah, it is. Let me try something real quick. Let's keep this afloat. Okay, so let's go stat. We want to go stat, down to our calculators. We want to go to normal. Now when we go to normal, okay, it's going to give us this thing. So I have 0, 0. Now look at this sign. I want this shaded region to look like this shaded region, so I just have to take greater than. Okay, now I need this red here to be to the right of 0.11. So see, these are my z-scores right here. See, these are z's. So I need to put 0.11 there. I just hit compute. That's my answer. Okay. So it says around to 4 digits, so 0.4562. Oops, check answer. Okay, you see? So let's go, that's how you do it. Now that says between, you see? This says, let's see, find the probability. Okay, between 1 and 2. So I want something in between, so it has to be shaded between. So that's between 1 and 2. So it's going to be C. Sorry, I got to check my answer. Okay, so now the probability of this one's a little different in that what we have to do here is we have to find the probability between 1 and 2 right here, the shaded region right here, between 1 and 2. Let me change the color up a little bit. I need to find that. But the problem is StatCrunch isn't going to do that for us. StatCrunch will do it, but what we have to do is StatCrunch will find this and this. Okay, so what we have to do is we have to get whatever this is. Let's call it A. We have to get what this is, which is B, and we have to add these together and then do 1 minus that sum. So it's 1 minus A plus B. Okay, so I'll leave it up to that. You do the same thing here. I'll show you how to get the one on the left, and then we could go from there. Okay, so stat. I'll get one, and then you could do the other one to get the idea. Okay, so I do want this shaded region first. I want this shaded region. This is my A. lost it again. Let me pull this back up. Get rid of one of those. In this instance, the left side, that's the left side. Now I want it to be less than 1. Less than 1. So here's my 1 right there. And compute. So write this number down as a whole. Don't round it. Okay? I just lost it. Not sure if I could keep that up front. But anyways, that number that just popped up there, write that down for A. The whole number. Don't round it. Write the whole thing with decimals. That whole number that I just had there. See if it'll pop up again. Okay, here. 0.8413. You write that here. Change this to a greater sign right here. Change this to a 2. That'll give you this side over here, which is B. Add those two together and then do 1 minus that. And that'll give you the probability of something in between. You have to be comfortable doing that. Okay? So the only other thing I want to do is scan through these and just see if, okay, that's just a shading problem. That's just a shading problem. Same problem. Okay, so here it's saying P87. So what the 87 is, the percentile means that it's everything less than 87%. Okay, the 85% is less than. Okay, so what that looks like on a graph is, let me get rid of these. So if I said P87, so here's P87. So what that means is that you took a test and you scored better than 87% of the people. So that's a Z, and you scored better than all these people, or you fell higher than them, whatever the data is. Okay, that means if there was 100 people, you were ahead of about 87 of them. Okay, so what you have to do is you have to find the Z this. So you just work backwards on your Z score. Okay, so it's mu equals 0, standard deviation equals 1. It's going to see the probability. I want the X less than here. Okay, remember, this is the Z and this is the area. Okay, so I want my area to be 0.87 and I need to find the Z. Okay, so first of all, it's C, because this graph looks like this graph. Now they're going to say find the temperature, so it's a Z's, so the temperature is just like a Z. So what we need to do is go to our StatCrunch and just like I said, and these transform to our other one. See, this is our Z's. This is Z's right here. This is the area. So I need this area to be 0.87. I say compute. And the Z is 1.12, so I need to round to 2. So 1.13, because this is a 6, so it's going to round that 2 to a 3. 1.13. Okay? So that's how you work backwards. So sometimes you're going to have to find, just like here, let me get rid of these. Sometimes you're going to have to, given a Z, you have to find a percent. Sometimes you'll be given given a Z, you have to find a percent. Sometimes you'll be given a percent. Sometimes you'll be given a percent and you have to find the Z. That's what we just did. Okay, let's move on to 6.3. Move on to 6.3, which is the same thing. We're just working. We're working with our raw data. Okay, we could always change our raw data to Z's, but with technology we don't necessarily have to. Okay, so work with the raw data X. Everything kind of means the same thing. So here I could get out of here. Now there is one difficult one, but you just have to play around with these things. Okay, this is the middle. This is the middle right here. This 0.4648. That's the middle. So you have to. Here, let me just show you how to do this one real quick for 6.2, because this one's kind of tough. So this is 0, that's negative D, and this is D. Okay, so you have to say this middle is 0.4648. Okay, so all you have to do to find this one right here is to find this area. If you find this area and then go to StatCrunch and put this area in, my mu is 0, standard deviation is 1. Okay, I'm looking for a Z. I'm given whatever percent this is. Okay, so you need to do the probability that X is greater than Since I'm looking for a z, this is your z, just like I just said, and this is the percent. Okay, so let's look how to cut this up. All three of these, this percent and this percent are the same. It's the same because they're perfectly symmetric. So I need to find the complement to this. So to find the complement, I just do 1 minus 0.4648, divide that by 2, because see this part gives me this and here. That gives me these two as a whole, as a total. But I don't want that one. I'm only interested in half that. So if I want half of a number, I just divide this by 2. I plug this in here, and this is the answer right here in the StatCrunch. Okay? So that's how you do these two right here. Okay, same thing. 1 minus this divided by 2. Put this in your calculator just like this, or greater than, and you'll find it. Okay, so let's get rid of this real quick. Now working with the raw data is basically the same thing as working with the z's. It's just you're working with go to here. Okay, so let's go to 6.2. Oh, I'm sorry, 6.3. Okay, so you have a lot of here, but you know most of them are the same idea. Okay, so here's the z's. Okay, that you should know. You could work on number 1. But I'm just going to show you a couple of these. Okay, find the area. Okay, mean and standard deviation here, and this is 70. So it's the same thing we just did. It's the same exact thing. We're just using. Okay, we're using x's instead of z's. So look, I need this is 70 right here. This is 70. The mean is 100. I'm looking for this 70 shaded here. So we just use StatCrunch. So don't worry about the tables. We could use technology. Make this smaller. Let's go and allow that. Okay, so we want to go stat. We want to go stat. Go to our calculator. If it ever comes up. Okay, well this thing's going. Oops, it disappeared. Not that. This. Okay, let's go ahead and get in it again. Looks like StatCrunch is taking a break. Huh. Okay, I'm back. Let's go keep these afloat. Okay, so let's go to let's say number 3. Oh, anyways, basically, when you're on StatCrunch, if you're on u equals 100, let me pull that back up and get this thing where it's. For some reason this thing's giving me trouble, but mu equals 15, and I'll just show you. And this would be the probability. Okay, I'm on a less than here, so I'm going to x equals less than. Now remember, this isn't a z anymore, these are your x's because I'm dealing with the raw data, and this is the percent is a decimal. Okay, so I want less than 70, and that's going to be your answer. Okay, for some reason this thing's giving me some trouble. I'm going to have to edit this stuff out. Okay, so let's try this one more time. Sorry, you have to take a long time here. Oh, God. Okay, so my computer's giving me some trouble tonight. But you get the idea. It's the same thing as it's the same exact thing as the z's. It's just we're using x's. Okay, so since I have this up, I'll just go ahead and show you how to use this here. So I go second vars, and I want to do a normal CDF. Normal CDF. This is how you get this answer. So my lower bound, okay, my lower bound is going to be way over here. Way over here. Some data point that's just never going to happen. Like negative 1,000 will never happen. Okay, so I'm going to go negative 1,000, comma. My upper bound is 70. Because that's where this is all my shaded region. I'm interested from negative 1,000 to a 70, comma. I want to end it at my mean is 100. My standard deviation is 15. Okay. So this is how you do it on StatCrunch. That's how you do it on StatCrunch. And this is how you do it on TI. So the answer there is 0.02275. Okay, about 2.275%. Okay, so let's talk about some other ways real quick. They could ask you here 100. This is normal with 115. They could say find the data for P75. Okay, so P75 would be where the shaded region over here is 75%. So here it's just like before. They could give you a percent and you could find this data point, but not as a z, as an x. So this would be mu equals 100 in StatCrunch, standard deviation equals 15. Okay, which way am I shaded? I'm shaded to the left. So x shaded to the left. This is going to be your answer as an x. And this is where you need to put the percent. Okay, so there's going to be some questions like that. Okay, there's going to be some between questions. So just if you could do the z's, you could do the x's. It's the same, basically exact same thing. Okay, so I'm just going to pull this up one more time to see if I have any luck. Okay, so see 103 and 15, you need to find the third quartile. That's okay, which is the IQ separating the top 25% of the others. Okay, that's just what I asked. This is the same exact question I just said. Okay, this is actually your Q3. This right here is your Q3. It separates the top 25% from the bottom 75%. That point right there, which is this guy right there. So the only thing you would change to do that problem, since it said 103, was 103. Okay, so let's see if I can pull this up, see if it wants to work this time. Stat calculator. Let's go to, oops, don't want that. Stat calculator. Okay, see, the third quartile means that 75% falls to the left, okay, which is the IQ score separating the top 25% from the others. So you could do this two different ways. The mean is 103, the standard deviation is 15, okay. I want, okay, so you could do this two different ways. This could be a 75. If this is 75, I want to do a less than. 75 less than, so it'd be 113. 113, okay. Or I can make this thing a 25 and do it greater than. It's going to give me the same exact answer, 113, okay, because I'm looking for this data point right here. Over 100 less than 120, so 113, okay, round to 113.1. So that's going to be a 113.1. Check answer, okay. So that should cover you to get you through 6.2 and 6.3, okay. So thanks for watching and good luck.